Hi, I'm Bryant for your tutoring high school biology. Today's topic, chemistry. Yes, you will need to know some chemistry for biology, but not that much, and we'll hit it now. First up, all matter is made of atoms. Everything that's a solid, a liquid, or a gas is made of atoms, these tiny particles. Here's a diagram of the helium atom. All atoms have a nucleus in the center, with positively charged protons and uncharged neutrons. Circling the nucleus are the negatively charged electrons. The different types of atoms are known as elements. Each element has a different number of protons from any other type. Also, each individual element has the same number of protons in the nucleus as electrons circling around. This also means it has a net charge of 0, since every positive charge from a proton cancels out a negative charge from an electron. The other thing about elements is that they're generally unstable by themselves, and so they'll form bonds to become more stable. The two types of bonds they can form are ionic bonds and covalent bonds. In an ionic bond, electrons will be transferred. Let me show you. Here we have sodium. It will give up an electron and give it to chlorine to make sodium chloride, or common table salt. Now remember, elements have the same number of protons as electrons. However, sodium is losing an electron. That means now it has more protons, so it becomes positively charged. Chlorine is gaining an electron, so it becomes negatively charged. The other type of bond is a covalent bond. That's when elements will share electrons. Here we have hydrogen and oxygen, and each hydrogen will share one electron with oxygen. Likewise, the oxygen will share one electron with each hydrogen. This creates H2O, or water. The thing about covalent bonds is we can figure out if they're polar or nonpolar. In a polar covalent bond, they will have both a positively charged end and a negatively charged end. In nonpolar covalent bonds, the electrons will either be grouped in the middle or pulled out to the side, so that there's really no positive or negative pole. Water, in this case, is actually polar. Let me show you how. Oxygen has a very strong electronegativity. It has a strong pull on electrons. That means they'll all be at the oxygen end, making that end very negative. Teachers will normally tell you if an element is strongly electronegative. Oxygen happens to be one of them. Because the electrons are pulled away from hydrogen, pretty much just the protons are at the hydrogen end, and those are positive, so the hydrogen end becomes positively charged, and this whole molecule is polar. For more information on ionic and covalent bonds, check out my videos on those topics. Something cool happens when you put nonpolar substances next to each other. They'll start to stick. This is known as a van der Waal interaction. It's the same thing that lets some lizards climb walls. Their nonpolar feet will stick to the nonpolar substances in the wall and allow them to scale it. Now, even after bonding, elements can still become more stable by going through chemical reactions. Here's a picture of what might happen in one of them. Two iodines bonding to two oxygens. Now, of course, the iodines are already bonded to each other, and the oxygens are already bonded to each other. This also illustrates the idea of collision theory. Collision theory says that in order for a chemical reaction to happen, the two reactants, the things that are reacting, have to collide with enough energy and in the right orientation. Enough energy is understandable enough. If they don't hit hard enough, then the bonds bonding these guys together and these guys together won't break, and they'll just bounce off each other. As for orientation, let me show you. Let's reorient the two oxygens so that they're coming in sideways. Now, when they hit, this I could bond to this O, but that leaves this I floating away and this O floating away. Since those are alone, and it's actually less stable than earlier, so this chemical reaction will not happen. As a consequence of this, you usually have to put a lot of energy, or at least a certain amount of energy, into reactants to have them bounce around, and so they'll randomly hit each other with enough energy and with the right orientation. Most collisions won't have either enough energy or the right orientation, or even not have both. The energy you put in to start a reaction is known as the activation energy. We can illustrate that on a graph. This graph shows any general reaction with the energy of the reactants up top, and here the energy of the finished products, the products, at the bottom. There is one other type of reaction where the products will actually have more energy with the reactants. That looks like this. But in both cases, the activation energy is the hump. Now, there is a way to lower the activation energy, and that's by adding a catalyst. Catalysts cause the reactants to bond in the right orientation every time. What will happen is the reactants will bond into the catalyst, and then the catalyst will change their orientation to the correct one. That way you don't have to put in energy to cause random collisions, only energy so that they collide with enough energy. The action of a catalyst is shown on graphs usually by drawing a dotted line that is a lesser hump. We're going to talk about enzymes, an organic type of catalyst. That just means they're made of stuff like carbon, hydrogen, and oxygen. With enzymes, we're going to have the reactants bond in. And this used to be believed to be a lock and key mechanism, that the substrate, the reactants, would fit perfectly into the enzyme. This is not the model we use now. Right now we use what's called the induced fit model. It means the substrates, the reactants, will fit almost into the enzyme, but in bonding will change the shape of the enzyme to fit perfectly. The enzyme will then bring the reactants together in the correct orientation and cause them to bond. To recap, all matter is made of atoms. Anything that's a solid, a liquid, or a gas is made up of small particles. These atoms have a nucleus made of positively charged protons and uncharged neutrons. This nucleus is circled by negatively charged electrons. The different types of atoms are known as elements. Each element has a different number of protons from any other type, and also have the same number of protons in the nucleus as electrons circling around the nucleus. Elements, however, are generally unstable by themselves. They'll form either ionic bonds, where electrons are transferred, or covalent bonds, where electrons are shared. In covalent bonds, you can check if they're polar or nonpolar by seeing if there's a negatively charged end where all the electrons are, and also a positively charged end where the electrons are away from. In nonpolar covalent bonds, the electrons are either grouped in the center or spread around the outside of the molecule. Nonpolar substances can stick to each other through van der Waals interactions. When a chemical reaction happens, the reactants have to have enough energy and collide in the right orientation in order for it to actually occur. This will make the elements generally more stable, but you'll need to put in energy to get them to bounce around and randomly strike in the right direction and with the right energy. This is known as the activation energy and can be shown on graphs as the hump. You can lower the activation energy by adding a catalyst, which bonds the reactants in the correct orientation. An organic catalyst is known as an enzyme. Enzymes work through the induced fit model. The substrate, or reactants, will bond to the enzyme and change its shape so that they fit perfectly into the enzyme. Alright, that's all for now. Again, I'm Bryant. See you next time.